So now we are going to solve some PYQs from SQL. So the questions that I'm going to solve today are from the older years of CST, which are from early 90s, late 90s and early 2000s, and they are mostly subjective questions where you have to write queries or explain in an English sentence like what is the meaning of this query. So I'm going to mostly solve those questions, and the rest I'll give in quiz so you can attempt that. Okay, so let's start. So let's see this question from CSE 1988. Okay, so it's saying describe the relational algebraic expression given the relation returned by the following SQL query. Okay, so we know that an SQL query, a basic SQL query, you can always write a relational algebra expression and vice versa, right? You can convert a relational algebra expression to an SQL query, and similarly a SQL query can be written as a relational algebra expression. So we have to write that only. So they have given us a SQL query, okay, and you can see that it's a nested query. So we have to see how to solve this. So it's saying select S name from S where S number in. So there is no other information given. So we have to retrieve all the information from the query itself. So there is a table called S, right? It has two attributes. At least we know that there is an S number and there is S name. Okay, so S name and S number is there. Then select SNO from SP. So there is another table which is SP. It also has SNO, right? And from this where PNO. So it PN because it's condition on this SP table. So it means SP table also has this PNO. Okay. Now there is this another nested query. So we have another table which is P, which is mentioned here from P. We have to select PNO. So PNO is here and where color is equals to blue. So there is a column called or attribute called color. Okay, so we have three tables. S has S name and SNO. SP has SNO and PNO, and P has PNO and color. Okay, so we'll start from the innermost query and see. So it's not a correlated query, right? You can see very clearly it's not a correlated query. It's a nested query. So they can be individually computed. So first of all, we'll look at this query, what it's trying to do. So it's doing select PNO from P where color is equals to blue, right? So we'll start solving this. So we'll say select, right? So we are selecting from P, right? Select such that color is equals to, this is selection operation, right? Color is equals to blue, right? So this is color is equals to blue queries with selection, right? Now this is where condition that you have established using a select in relational algebra. Now you will do the select here, right? Which is basically the projection of relational algebra. So you will project the PNO from P, right? So this is your table finally, correct? Now, now this is the first query that we have solved, right? Now from here, from this PNO, you are going to select. Now you have to select the PNOs which are in this, right? From SP and this, right? So we kind of only have to select those PNOs which are present in this whatever you have retrieved, right? So you kind of have to do a join now. So what you will do is you will take this query over here, right? And here, right? So this will be some result that you will be getting. So in this you have a PNO and you have a SP table where you had SNO and PNO as well, right? So you can do a join, natural join. So let's see, this is natural join, or you can write natural join, or you can write where, or I'll say that this is natural join. Okay, so this is natural join, right? And I'll join it with SP. Okay, now I have joined it with SP, right? Now this is till here that you are selecting. You have joined this. Now you want to select SNO from this merger, right? So you are selecting all the SNO from the SP such that the PNO is in this particular these particular PNOs, right? So now those PNOs you have already extracted. Now we have done a natural join of SP and whatever PNOs are. So wherever the PNO matches the SP PNO, those rows will retain, right? Now from here we have to select only the SNOs, right? So we'll do selection of SNOs, or you will say projection. So this select is synonymous to projection in the relational algebra, and where is basically selection, right? So So we have written till here, right? This is done. Now here you are projecting SNO. Now your query is that you have to select S name from S where SNO in, right? So this whole thing will be returning you a table with SNOs only, right? Now you have to join it with the S table, right? So you will do a natural join. So this is natural join, and then you will do projection of S name, right? So this is your full query, right? So I have written this query in a better way. So this is like this. So you will first do selection operation, which is synonymous to where in the SQL query. You will find all the rows which have color is equals to blue, and then you will select only the PNO, or you will project only the PNO. Now you will merge this, or you will take a join. So this is natural join. You will take a natural join with SP table, and you will select only the SNO, right? So you are doing a projection in relational algebra, which is SNO. Then you are joining it with the S table, and you are projecting only the S name, right? So this is your final answer. Fine? Okay. Now let's move forward to the second question. So we have this question from GATE CSE 1990. Okay. Consider the following relational database. Now they have given us some relational schema. So this is relational schema as we already know it. Relational schema. Okay. So they have given us three tables. So one is employees table, other is projects table, and other is working table. Okay. And they have some attributes in them. The queries regarding the data in the above database are formulated below in SQL. Okay. So they have given you some query in SQL. You have to describe in English sentences the two queries that have been posted. Okay, so this is the first query, and I have posted the another query in the second page. So we'll try to first solve this query. Okay, so I have expanded this query, and obviously I'll have to copy these tables over there so that we can look at them and try to understand what this query is doing. Okay, so this is your relational schema. So this is the relational schema. Fine. So let's look at the query. So this is again a nested query, right? So we have to see what the query is doing. So it's selecting the name of the employees from employee table where employee number is in. Now how are we finding the employee numbers? You have to find the employee numbers from working table by grouping them by E number, having count is equals to, and you have to select count star from projects. Okay, so we'll start solving the innermost query first, and then we'll move upwards. Okay, so let's solve this query first. So this is doing select count star from projects. Okay, so let's look at the project table. So it has PNO, P name, and number of staffs allocated. Okay, so basically this is the information about the projects that are there in a company. Okay, so count star will give you the number of all projects in projects table. Okay, so how many ever projects you have, it will return that, right? Now it's saying select the ENO from working where group by E number having count star is equals to this. So now we have to, so now let's look at working table. So working table has ENO, P job, and P number. Okay, so when we group by ENO, right? So for every employee we are grouping, and then we are using count star, right? So when we group the table, when we group all the rows, combined rows, we suppose you have a table here like PNO, ENO, and P job. Okay, and you have P number. PNO is ENO say 1 2 1 1 1, right? And say 1 2 1 2. This is 2 3 4. Okay, suppose I have to group by ENO, right? So all the rows which have ENO is equals to 1 will be grouped together. So this 4 rows will be grouped together, and then having count star. So and now this will be counted, right? So we know that having count star, having basically operates, it does a filtering on the groups created, filtering on groups, right? So we'll create a group by the employee number, the E number, and we'll count how many rows each group has. So if this is our table and we group, then employee number 1, ENO1 will have 4 rows, and employee number 2 has just 1 row, right? So we are saying the number of rows should be equal to how many ever number of projects you have in the project table, right? So when will an employee has this count equal to the number of projects? So the employee will have the count star equal to the number of projects when there is an entry with EN number, with the employee number, and correspond like every project corresponding to this, we have every project in the table, right? In that case, your employee will be associated with every project and count star will be equal to the number of projects that you have. Hence, so this is basically telling us that you are selecting the employees in like employee numbers such that they are associated with all projects or with all projects from projects of project table. Okay, so they must be associated with all projects of project table, then only that employee number will be selected. Okay, now for those employee numbers you are finding the name of the employees, right? So find the name of the employees. So this is find the name of the employees. Name of the employees for selected E numbers, right? So what is it doing? So it's finding the name of the employees who are working on every project that is there in the projects table. Okay, so this is the, so we have to describe this. So this will give you the list of names for the employees who are assigned to every project in the projects table. Fine, so this is the answer for this query. Now this question has a second part where they have given you a second query. Okay, so let's look at the second query also. So now we have select P name. I'll copy the relational schema over here so that we can look at it whenever we need it. So this is your relational schema. Okay, so this is relational schema. So there are 3 tables again, and we have to find the meaning of this query. So you have select P name from projects where P number in. Okay, so you are selecting the name of the projects from project table where P number in. Now we have to be selective about the project numbers, right? So let's try to understand what is these project numbers. So you have select PNO from projects, right? So these are basically all the projects from project table, project numbers from project table. Okay, then you have select distinct PNO from working. Okay, so these are all the projects where you know some employees associated. These are all the projects with which some employee is associated. Or you can say some employee is already working on this project. Okay, so when you do projects, all projects minus those projects on which some employee is working on, what are you left with? This minus will give you this whole combined query, right? This basically gives you project numbers on which no employee is working on, right? So these are the set of all the projects that you have. These are the sets of projects which are basically associated with some employee, right? Some employee is working on this, and the entry will be in the working table, right? So so if we minus them, they basically will be the project number on which no employee is working, right? Now for those projects you are finding the project name, right? So what is this doing? This is doing project name for projects on which no employee is working on. Fine. So this is simple. So the answer is projects that have no employee associated with them. Okay, so this is the question from GATE CSE 1990. Okay, let's move on to the third question. So we'll do the third question now. So again, they have given us a schema. They have given us a database schema which has 4 relations. So there is a supplier relation, there is a part relation, there is a projects relation, there is a SPPR relation. Okay. Now we have to write SQL queries now. So as I already told you, the earlier years of CSC had subjective questions where you had to write answers in lines or you would have to write queries. So that's why here we have to write queries. So let's try to write the queries for the given statements. Fine. So the first statement is print P code. So here is the P code. We have to print the P code values for parts supplied to any project in Delhi. So this is Delhi. So this is incorrect. This is Delhi. Delhi by a supplier in Delhi. Okay. So let's try to understand what these tables are. So there is a supplier table. So it will basically have the supplier code, supplier name, and supplier city. Now there's a part table where you have part code, part name, then part destination maybe, and then city. Okay, and then you have project code, project name, and project city, and then you have SPPR. So it's basically, I think, the supplier code, the part code, and the project code, and the quantity, like which supplier supplied which part to which project in with what quantity. Okay, so this is kind of aggregation, like it has information about all these 3 tables. Okay, now we have to find the P code values for the parts that are supplied to any project in Delhi by a supplier in Delhi. Okay, so where will I find the information about the projects? So I'll find the information about the projects in the project table, right? So I have to use the project table here, any project in Delhi, right? And so basically PR city should be equal to Delhi. Okay, then we have to find the by a supplier in Delhi. So the supplier should also be in Delhi. So hence I have to go to the supplier table also, and then I have to query the city as well. So basically supplier.city should also be equal to Delhi. Okay, so I have taken care of this part and this part. Now I have to find the information about the P code of values that are supplied to any project in Delhi by a supplier in Delhi, right? So I have to find the information about the parts that are supplied, right? So how will I do that? So this information is present in SPPR table, right? So this is the table that I'll have to use, right? So here SPPR table, what we'll have to do is this SPPR table has to have the S code to be equal to the code of the city, code of the supplier, which is here, right? S code should match, then P code should match to the P code I have to extract, and the project code, PR code should match to the city's code, which is in Delhi, right? So let's write this query and we'll see how to do this. So there will be 3 statements, right? We have select, we have from, and we have where. Okay, now there are 3 tables involved, so I'll have to join them, right? So I have to join supplier. So I'll use supplier as S. I'll say S. Then you have projects table. So you'll use projects as P, and you will have SPPR as say SP. Okay, so these are the 3 tables, right? Now I want to join all of them. So how will I join all of them? I will say S dot city. First of all, city should be equal to Delhi, right? And S dot P dot city should also be, project dot city should also be Delhi, right? Because these are both from Delhi. So this is also Delhi, right? Now I have done these 2, right? I have taken care of these 2. Now I have to join them, right? So here I have to do this, and now I have to join this with this SPPR table, right? So I have to say SP dot sp dot s code is equals to s dot s code, right? So I have joined this table with this table to extract the correct code. Now I have to join it with, so I'll remove this, okay, and I'm writing it here. So this is and also you have to ensure that the PR code, the project code also matches, right? So PR code, you have to use p.pr code. P.pr code is also equal to sp.pr code, right? And there will be an and which will be coming here. So I'll just move it little here, right? And this will be and. Okay, now you have joined all the tables. Now you have secured all the rows that you want. All you have to do is you have to find the p code, right? You have to find the p code. So you'll do p.sp.p code, sp.p code, because p code information is now present only in the sp table, right? Sp table over here. So sp.p code as p code. Fine. So this is your full query. So you will write select sp.p code from SPR as SP, project as PR. Obviously you can use a different name. I have used project as PR and supply as SU. And then you are doing sp.pr code is equals to pr.pr code. Basically p.pr, the PR code should match, the S code should match, the city should match, right? So PR code should match, the S code should match, the city should match, and that's it. Fine. And then you will be extracting sp.code as p code you can do. Fine. So this is your final query for this. Now let's do the second statement. Okay. Now you have to find, so this is a slightly trickier query. So you have to find all the triples or all the triplets, city, p code city, such that supplier in the first city supplies the specific part to a project in the second city, but do not print the triples in which two city values are same, right? So this person, so this is supplier city and this is project city, PR city. Okay, so then such that a supplier in the first city supplies the specified part to, obviously this is the part, to a project in the second city. Okay, so how will we do that? So city information is sitting where? So city information for the project is sitting in here, right? Here is the project information. So here we'll find the city information, here we'll find the city information, right? So we'll first have to find the city. First of all, we'll have to find the S code. From S code we'll get the city information, right? From PR code we'll find the city information from this table, and P code is already there, so P code is there. So our main table that is going to be there is SPPR. Okay, so let me move it to another page so we have more space. So I'll copy this whole query, I'll put it here. And this is my relational schema that I want to use. Okay, this is your relational schema. Okay, so the way you will do this query is, first of all, you will start, you have to select. So there are three parts to it. Select from where. Fine. Now select from, so you have to use all three tables. So you have to use supplier table, so use supplier as SP or S you will call it. Then you have projects table as P, and then you have SPPR as SP. Fine. Now you will use select. Okay, so you have now let's do this the join conditions. Okay, so you have to join three tables. So how will you do that? So first of all, you have to join the S table with SP table. Okay, so you will do S dot S code is equals to SP dot S code. Okay, and p dot pr code is equals to sp dot pr code, right? So now we have joined these three tables. Fine. Now we have to so p code anyways we don't have to join because we don't want to get a city information from p code. Now we have to just ensure that the first city supplies the specific part to the other city, but they should not be equal to the same city. Okay, so it should happen is s dot city should not be equal to, or we should write not equal to p dot city. Okay, and we have to take in s dot city, then we have p code, and you better to use like sp dot p code, so we'll do sp dot p code, and you can use aliases properly to rename them, and this is p dot city. Okay, so this is how you will write the final query. Okay, so you have supplier dot city, then sp dot p code, pr dot city, supplier is su, projects is pr is sp. You are ensuring you're joining the tables, so you're joining sp table with su table, sp table with pr table, and you're ensuring the cities are not same. So this is how you will write the query for this given statement. Fine. Okay, now let's do the fourth question, which is from GATE CSC 1998. So suppose we have a database consisting of following three relations. So they have given us three relations: frequent, serves, and likes. Okay, what is the frequent table has? It has a student attribute, it has a parlor attribute, giving the parlors each student visits. Similarly, serves has parlor and ice cream, indicating what kind of ice cream each parlor serves. Then you have a likes table where you have a student and ice cream, indicating what ice creams each student likes. Assume that each student likes at least one ice cream and frequents at least one parlor. Okay, so we have to assume that every student likes at least one ice cream and at least one parlor is there that they visit. Then you have to find the students that frequent at least one parlor that serves some ice cream that they like. Okay, so we have to find the students that frequent at least one parlor that serves the ice creams that they like. Fine. Okay, so now we'll have to so let me extract this information, everything here, and put it to a new slide where we can work on this query. And this is the query that we have to solve. Fine. Okay, so first of all we'll see what all relations do we want. So we want students, right? So student information is there in the frequent table and the likes table as well, right? Then you have frequent information, at least one parlor that serves. So serve information is definitely there in parlor and ice cream tables. It's in this serves table, right? Parlor, which parlor serves which ice cream, and some ice cream that they like. So this is in likes table, and frequents is in this table, right? So we have to somehow use three tables, right? So we have to use all of these three tables. So we have select, from, and we have where, right? So we know that we have to use all of these tables. So we will use frequents F, serves S, and so I'm aliasing, I'm writing them likes. So I'm writing frequents as F, serves as S, likes as like L. Okay, now I have to join all of these three tables, right? So how will I join that? So we have to find, so first of all I have to find the ice creams that student likes and if some parlor serves it. Okay, so how will I do that? So I'm joining these two tables first. So the way I will do it is I'll say S dot ice cream, it's in small, so we'll write it in small. S dot ice cream is equals to L dot ice cream, right? So now I have the information of the student the ice cream that they like and which parlor serves them. Okay. Now I have to find the information about the visits of the student. So which student visits which table, which parlor, right? So that information is there in the frequent table, right? So we'll have to join these two, right? So we'll have to join the serves table with frequent table. So we have to do s dot student is equals to f dot student, right? So now this student frequents this particular parlor whichever we'll have, and right, and we also need to have that parlor which the student is visiting should be serving this ice cream, right? So we have to write that, we have to join these two table also, right? So this is just that we are getting the name of the so the students, so likes is basically, so here how we are getting the so till here we are getting the parlors names which are serving the ice cream the students like. Here we have joined the name of the students with the parlors that they visit. Now we have to join the information that students should also be visiting that parlor which serves the ice cream, right? Which they like. So what we have to do is we have to do s dot parlor should be equal to, so this student should be visiting the s dot the this frequency, right? F dot parlor. Fine. So if we do this, we'll get all the rows where student likes the ice cream, and that ice cream is being served by this parlor, and this parlor is being visited by the student. Fine. So we have joined all these three tables. We have done a natural join on all three tables, and now you have to find the students, right? So you will just do s dot student, or you will do like dot student, like l dot student as student. Fine. So if you do this, your query will be solved. So you have to do is you have to find, okay, you should use distinct clause also. So you will use distinct clause because there could be multiple ice creams that students like, and there could be multiple parlors that serve that ice cream that the student visits, right? So that's why, for that reason, you need to have a distinct clause as well. So the proper query will be distinct f dot student as student. Okay. So what we have done is select distinct f dot student from frequent serves and likes, where parlor, you have joined the parlor table with you have joined the frequents table with the serves table, you have joined the serves table with the likes table, and then you have joined the likes table with the frequent table. So all three tables have been joined together, and hence, and this with this you will get your result. Fine. Okay. Now let's look at this question, which is the fifth question from GATE CSE 1999. So they are saying which of the following is or are correct. So this is an MSQ question. So you have to select multiple if there are which are incorrect. So let's look at the statement one by one and see which of them are incorrect. So they are asking, so their first statement is an SQL query automatically eliminates duplicates. So this is incorrect, right? So SQL does not eliminate duplicates. We have to use, what do we have to use? We have to use distinct keyword. Use distinct keyword to do that. Okay, so this option is incorrect. Fine. Then let's look at the second option, which is an SQL query will not work if there are no indexes on the relations. Okay, so what are indexes? So we have now talked about indexes so far, but let me give you a brief insight into something that we'll be studying later in the course. So indexes means that you basically, suppose you have an attribute, say your primary key attribute. Okay, so suppose you have a employee table. Okay, so now you have employee table where you have, say, two attributes, e number and e name. Okay, and I say that e number is unique. Okay, so I have 1, 2, 3, 4 and so on, whatever you have, right? Now this e number is unique, right? So what I can do is I can create a hash map on this e number, so that whenever I need to access this record corresponding to the e number 1, I can go and quickly access it in the memory. If I don't create indexes, what I'll have to do is I will search through this whole table, whole e number, and I'll search. Suppose I'm searching for, see, my query is search for e number is equals to 3, right? So I'll have to go through every record and I have to find that number, right? But if I create index on this, so which is like, index is like a hash map. Indexes are like hash maps. So they are done to, faster access of your queries. So if I create a hash map, so when I say e number 3, I can just run that hash function. I'll do hash function e number is equals to 3, and it'll tell me the location where exactly is that record present, and I can just go and access that directly. Okay, so now the indexes, so the question is saying, okay, SQL query will not work if there are no indexes. So let me tell you that this is false. So even if you don't have indexes, the SQL queries work fine, right? You don't always have to end indexes. It will happen that your query will run slower when you are running that query, because when you create indexes on your attributes, they run very fast, because you can have, like, in very quick access you can have through the indexes. But if you don't have indexes, it doesn't mean that your query will not run. It just means that your query will be slower. Okay, so here it is incorrect, because indexes are used to make the queries faster, and SQL queries will work with or without them. Queries work with or without them. Fine. So this is also incorrect statement. So we have found out that these two statements are incorrect. Let's look at the third statement. So third statement is saying that SQL permits attribute names to be repeated in the same relation, right? So this is also incorrect. So when we started talking about relational, schema and SQL also, we said that SQL does not allow the same attribute name in the same relation. Okay, so SQL doesn't allow two attributes to have same names, right? Because if you have same names, and when you go and access the attribute with the a row with the attribute name, the SQL will not know which row and which value to access. So SQL doesn't allow the two attributes to have same name. Okay, so this is incorrect. So this is same name. So this is also incorrect. So the correct answer is none of the above. Okay, so none of the above statement is correct. Fine. So the answer is D. Fine. So now let's look at our sixth PYQ, which is from GATE CSE 1999. So this is your sixth question. We have consider the set of relations. So they have given us two relations. One is employee and one is department. Now we have to write the SQL queries too. So there are two statements that they have given to us, and now we have to find the SQL query for them. Okay, so let's look at them one by one. So we'll see the first query once. So they are saying that you have to find all the employee names who work in departments located in Calcutta and whose salary is greater than 50,000. Okay, so I want to find salary information which is greater than 50,000. So that I'll get from the employee table, and the department location is in the the department location is in the department table, right? So the location should be equal to Calcutta. This should be equal to Calcutta. Fine. Now I have to extract information from both of these tables. This means I'll have to somehow join them. How can I join them? I need to find a common attribute. So this is the common attribute, department number. Okay. So with this information, I will have to find it, right? And I eventually want to find the employee name, find the employee names, right? So this is going to be in the select clause. Fine. So we know how to write SQL query. We have 3 clauses. We have select clause, we have from clause, and we have where clause, right? So we'll write that first. Then we know what table we are going to use. We are going to use EMP table. So I'll say EMP E. Okay, I'm going to use alias, and then I have department table, which is DPT. I will use it as D, right? Now I will first join these 2 tables. So I'll say E dot depth number is equals to D dot depth number. Okay, now I have joined these 2 tables, right? Now I can do other conditions, which are the salary, which is E dot salary should be greater than 50,000, and the other condition is the location, which is D dot location, right? That D dot location should be Calcutta. So I will move this a little to the left. So I'll say and D dot location is equals to Calcutta. Fine. I have found all those employees which have the same department number as the employee department number, and the department location is Calcutta, and salary is greater than 50,000. I just have to find their names, right? So I'll say E dot, or I'll use a different color. So I'll use E dot employee name as employee name, right? Why am I renaming? Because if I do E dot employee name, it will come in the result table as E dot employee name. So I'm just saying the projection that you should do is employee hyphen name. Fine. Okay, so this is how the query looks like. So this is your answer. So you have to find the name of the employees such that they have the location as Calcutta, the department number should match, this is a join condition, and salary should be greater than 50,000, right? We are joining them both. Okay, fine. Let's look at the second query. Okay, so now for each department we have to find the number of employees with salary greater than 1 lakh rupees. Okay, so for each department, right? So we have to find for each department number, right? So the keyword is department number. So we have to need department number information, which is there in the employee table, the number of employees we can count. So it means we have to somehow use count here, and here we'll have to use group by, right? And with the salary greater than 1 lakh. So salary information is already there, right? So we only need to use EMP table over here, right? So how will we write the query for this? So we'll do select. So we have 3 clauses, right? We'll have to do select from, where, and also there is a group by clause, right? So we have to write group by also, group by, right? So we have to use only the EMP table, so we'll write EMP as E, right? Now what is the condition? That E dot salary should be greater than 1 lakh rupees or 1 lakh, right? So we have this condition. So we have solved this condition that the salary should be greater than 1 lakh, right? Now we have to do group by. So group by, what do we want to group by? E dot depth number, the department number, right? So we have taken care of this condition. Now I want to find the count, right? So I want 2 information in my result. I want the department number and the number of employees. So I'll write select E dot department number, depth number as depth number, and the other thing that I want is count. You can do distinct, or maybe not distinct. We are assuming that it will be distinct, but okay, let's use distinct. You have employee number, right? So employee number as number of employees, num underscore employee. Okay, so this is your final query, right? So you'll have select department number count employee number as number employees from EMP as E, where here you should have E dot salary and here you should have E dot department number. Obviously you should have E dot here, right? And or maybe you, if you don't want to use ellipsis because you have just one table, right, you can remove this portion. You can remove this, right? So this is the complete query. Okay, so this is our sixth question, right? Now let's move on to the seventh question. So this is the seventh question. Let's look at this. So this is from GATE CSE 2001. Okay, so that's asking, consider a relation examinee where you have registration number, name and score, where registration number is the primary key to score and score. Basically it should be and score is a real number. Okay, write a SQL query to list the registration number of the examinees who have scored greater than the average score. Okay, so first of all you have to find the average score, right? We have to find the average score. The second thing is you have to find the number of examinees who have scored greater than the average score. Okay, so this kind of seems to be a nested query. Okay, so we'll have to write a nested query for it. So let's see this. So first of all, let's try to find the average score. So we have to find select. So we'll first find the average score. How will we find the average score? So we'll do select AVG score, right, as average score, AVG underscore score from which table? We have to do it from the examinee table, right? And there will be no where clause, right? So this is my inner query. Now I have found the I found the average score, right? Now my outer query should be finding the students who have scored greater than this, right? So this is simple. We have to find select. We'll do select from and where, right? So where we know, where and from we know. So from which table? We have to do it from the examinee table only. So we have just one table, so we will do it from examinee table, where the what should be more? Score should be greater than, right? So it should be greater than the average score. So this is the average score. This particular thing is the average score. And now what you want to select? You want to list the registration number. So we will do distinct. And anyways, this is the primary key, so we need not use distinct. We'll just say reg number. Fine. So this is your query. So it's saying select registration number from examinee where score is greater than. There is a nested query. So this nested query, so this full thing is a nested query, right? So this is the inner query. Inner query calculates its average score of average score. Fine. So this is how we write this. So you have select registration number from examinee where score is greater than, select average score from examinee. Fine. Okay. Now let's look at the 8th question. Okay, this is again from GATE CSE 2001. So this is the 8th question. So now they are giving us examinee relation again. Consider a relation examinee where registration number REG number is the primary key and score is a real number. Suppose the relation appears. So there is a relation appears now. Registration number center code specifies the center where an examinee appears. Okay. Now you have to write a SQL query to list the center code having an examinee of score greater than 80. So you have to list all those center codes where an examinee has scored more than 80 marks. Okay. So what do we want? We want the center code information, right? So this is present in this table and the score information present in examinee table. So we have to somehow join these two tables. So let's see how to write this. So you have select from where, right? So where do you have to select from? So we have to use both tables. So we'll do examinee and I'll use aliases because who will write examinee and appears again. So I'll say examinee as E and I'll say appears as A. Appears as A. Okay. Now I have joined them, right? Now I'm saying, so how will I join this? I will join this using regional number because this registration number is common between both these, right? So I will have to specify join. So I will do join. How? We will do reg number, sorry, E dot reg number. E dot reg number is equals to A dot reg number, right? Now I also want a condition where score is greater than 80, right? So this is the condition we have. So we have to write that E dot score is greater than 80, right? And that's it, right? For these joined tables, now we have to find the center codes, right? So we'll do A dot center code, center underscore code as center code. Fine. So this is how you find all the center codes having examinee greater than score, right? Now see, so here you will have from one center code there might be multiple people scoring the same scoring more than 80, right? So because SQL automatically doesn't remove the duplicates, we should have distinct. Okay, so we should actually use distinct keyword because when these kind of queries are there, we would want to see distinct codes. So we'll do distinct A dot center code as center code. Okay, so this is your final query. So we'll do select distinct A dot center code from examinee as E and appears as A, where E dot reg number is equals to A dot reg number. This is just for joining these two tables. So this is the join condition, and your E dot score is greater than 80. Fine. So this is how we solve this question. Now let's look at the 9th question for today. We have this question from the GATE CSE 2001 again. So we have consider the set of relations shown below and the SQL queries SQL query that follows. Okay, so there are 3 relations that they have given to us, and so the relations that they have given us: students, courses, grades. Fine. And we have select, this is the query that they have given. So this is some query and they are asking which of the following sets is computed by the above query. Okay, so we have to tell what does this query do. Okay, so before even looking at the options, let's try to dissect this query. Okay, so we'll do this query individually apart from these this thing, and then based on our understanding we'll come back to the options and see if anything matches our understanding. Okay, cool. So we have the students table, course table and grades table. So they are saying that select distinct name, okay, from student. So now this name is only present in the student table, right? Nowhere else name is present. So there is no conflict between the attributes name, and hence they have not used like a proper name, like a dot operator and this. So this name of this thing must be student name. Okay, so this is student name. Fine. From students, courses and grades. So they are using 3 of these tables. Now they are joining these tables, right? So student dot roll number is equal to grade dot roll number. So the roll number and roll number is common in students. So they have joined these 2 tables. Okay. So they have joined these 2 tables. Course dot instructor is Korth. So they are saying course dot instructor is equal to Korth. Okay. And they are saying courses dot course number is equals to grades dot course number. So courses dot courses dot course number is equals to grades dot course number, right? So these 2 have been joined, right? Using this particular equality, they have joined these 2 tables, right? They have been joined. Fine. And they are saying grades is equals to grades dot grade is equals to A. So they are saying grades dot grade is equals to A. So this is equal to A. Okay, so let's try to construct what this is doing. So they are saying that you have to find the students which have scored grade A, right? Because this student and grades table has been joined by roll number. So this grade will be of a particular student for whom you are trying to find the name, right? So this particular student should have scored A. Okay, So we'll write this student name, right, with A grade, right, plus. Now there is a condition course.instructor. Now in whatever course this grade is, now this course is being joined with the course table, right? So this course number is being joined with this. So whatever row will have this grade A is equals to A, that course number should be equal to the course number from the course table, and course table has a condition that the instructor should be Korth, right? So the condition is course is taught by Korth as instructor. Okay, so these are the three things which are happening. So what is doing? So you have to find the name of the students who have scored A grade in a course which is taught by Korth. Okay, so let's see if we have this in options. So we have name of students who have gotten A grade in all courses taught by Korth. So there is no condition such that there should be all courses taught by Korth, right? Because if it would have been all the courses taught by Korth, we would have first extracted the information of all the courses that Korth has taught, right? And then we would have been filtering such that okay, all the courses students should have taken, and then it should have scored A in all of those courses, right? So this is not correct, right? So here there is no condition as all courses, right? So this is not correct. You have name of students who have got an A grade in all courses. This is also not true, right? So there, in this sentence we are not mentioning anything about Korth, but in the query we know that the instructor should be Korth, right? Let's look at the C statement. Name of the students who have gotten A grade in at least one of the courses taught by Korth. So this is correct, right? So here we are finding the name of the students. If any of the course where the instructor is Korth and the grade is A, that student will make it to the result, right? So here we will only have students who have an A grade in at least one of the courses that was taught by Korth. So the answer is C. Fine? Okay. So the answer for this is C. Okay. So this is the 9th question. Let's look at the 10th question. Okay. So this is from GATE DA 2024. So this is the 10th question. Now we have consider the following two tables named radar and team in the relational database maintained by a Kabaddi league. So there is some Kabaddi league and it's maintaining two tables, which is radar and team. Okay. The attribute ID in the table team references the primary key of the radar table ID. Okay. So radar table has this as the primary key. Okay. I'll use a darker color. So this is the primary key. Okay. And the ID attribute is referencing this. So this is referencing this. Okay. Now they are asking us the SQL query described below is executed on this database. So they are executing this particular query and they are asking us to find the number of rows returned by this query. Okay. So let's do the query on this and try to find it. So what is this query doing? It's saying select star from radar and team. Okay. Where radar ID is equals to team ID. Okay. So this is the join condition, right? This is join condition. So we have joined the two tables on the ID. Okay. So we have joined these two tables on the ID and we are saying city is equals to Jaipur. So we have city is equals to Jaipur. So Jaipur, so only this will remain and only this will remain and only this will remain. Okay. Only these three rows will remain. Okay. So we are here. So I'll remove these rows. So we'll remove these rows. Okay. So we'll remove this row and we'll remove this row. Okay. And so this is, so we have reached here. So it's here. So I'm just showing it to you so that you are able to understand it better. Obviously you don't have to do all of this. You don't have to write it down on a paper and do like this. You can, if you understand your SQL queries well, you can do it very quickly. Okay. But so that we understand this properly, I'm doing this. So now the next step is, so I've taken care that the city is Jaipur. Okay, and I have to do rate points is greater than 200. So I have to remove all those entries where the rate points are not greater than 200. Okay, so what rows will be removed? So we have here rate points is greater than 250. Here rate points are greater than 200. So this is fine. Here this will be removed. The next row will also be removed, and rest all of them will stay. Okay. Okay. So we have this table which is here. Okay. We will move it up. Right? Now we have moved it up. Now also observe one thing. So we have done a natural join here, right? Because we had a join condition such that ID should match in this ID, right? So we should only have rows here where the ID matches. So 1 matches with 1, 2 matches with 2, and 5 doesn't match here. So we should actually not have 5 here, right? So here this gradar dot id is equals to 5 doesn't have a match. Match in team table, right? So it will be removed, therefore removed, right? So we'll remove this will remove, Pratham will remove, and we'll be left with only Gopal in this table, right? Now okay, now when we are joining this, what will happen? This so when you are doing radar and team, we are joining, right? So this will be joined like this. We'll have this radar table, we'll have this here, okay, and there will be city, ID and bits. And because we are doing a natural join, so ID will not be there, but I'm keeping ID here just to show. Okay. So now you have city. So you are doing a natural join, right? So one will be joined with this second row. So you have this row which will be put here. Okay, and then you have second. It will be joined with this, right? So we'll put it here, and then you have the third row will be put it here with corresponding to Gopal. Okay, so this is going to be your final table. This is coming from the team table, and this is your finally joined table. Now you are doing select star on this. You are doing select star on this. Select star on this. So how many rows are there? There is first row, second row, and third row. So the number of rows returned are 3. Okay, so the final answer is the number of rows which are returned by this query is 3. Okay, so you don't have to do it so elaboratively. The way I would have done is I would have checked that okay, Jaipur is there, Jaipur is there, Jaipur is there. Then there is a natural join. So this is natural join. So I have to only look at wherever this ID is matching this. So 2 is matching here. So 2 is matching here. Then 1 is matching here, 1 is matching here, and then I would have seen Jaipur 6 is matching here, 6 is matching here, right? Then rate point should be greater than 200. So rate point should be greater than 200. It's greater than. Okay. So now in this, just what I've said now on this slide is all that is required to determine that there will be 3 rows in the result. Fine. So this is how you quickly can solve it, but this I have shown you in a very elaborated fashion how this query will work. Fine. Okay, so this is from GATE DA 2024. Okay, fine. This is incorrect. This is GATE DA 2024. Okay, now let's do this question from GATE IT 2006. So they have said that consider a database with 3 relational instances shown below. The primary keys for drivers and car relation are DID and CID respectively. So DID and CID are the primary keys for the relation drivers and cars. So you have a drivers relation, you have a cars relation. So DID is the primary key here and CID is the primary key here. Okay. and the records is stored in ascending order of this primary key as given in the table. So they have said that this has been already sorted in the primary key according to the primary key in ascending order. No indexing is available in the database, so no indexing is available. What is the output of the following SQL query? Okay, so they have given you a nested query and they are asking you to find the result of this, and they have given you 4 options. Okay, so let's look at this query. So first of all, see that this is a nested query and not a correlated query. So these can be computed independently, right? So this can be computed independently and this can be computed independently. So that's what we are going to do. We are going to first compute this query, which is first this one, and then we'll do this query. Okay, so let's look at the first query, which is select r.did. Now r is a reserves relation. r.did from cast.c and this is a comma, reserves are, where r.cid is equals to c.cid and c.color is equals to r is equals to red. Okay, so what is happening here? So in this particular query, they are sort of taking a natural join, or they're joining the cards relation and the reserves relation. Okay, and there is an additional condition that the color of the car should be red. So let's first find the rows which have color red. So we have this Renault car which is in color red. So this is the one, and then you have this car which is Jaguar. This is also in red color. Okay, so you have these two cars which are in red color. Now they need to be merged with the reserves car. So we have to find all the rows where CID is equals to r.cid. It means that we have to look in the reserves table wherever the CID is equals to 102 or 104. Okay, so 102 is here, then you have 104 is here, 102 is here, 104 is here, and 102 is here, right? So these are the rows that you will get. So these are the rows that we will get. Okay, so we'll just mark them that this is the result of the first query that we have. Now from here, sorry, this is not the one, this is the one, and now we have to find the results of the second query. Okay, so let's find the results of the second query. So the second query is, so the first query is this, right? And we are selecting just the r.did, right? So we'll just do r.did. So if you select r.did from here, you will have 22, 22, 31, 31, 64, right? So you'll have 22, 22, 31, 31 and 64, right? So this is the answer of your first query. So this is what you'll have as r.did in the first query. Now let's do the second query. So the second query is r.did such that the color of the car should be green now. Okay, so the color of the car should be green. It means we have to look for this Ferrari car which is of CID 103. So we have to find all the rows in R such that, or reserves table such that the CID is equals to 103, and that's it, right? And we have to pick the DIDs, right? So R03 is here, R103 is here, R103 is here. So these three rows have CID 103. So we have these three rows coming in our answer, right? And now we have to pick what value from this. We have to pick, so r.did from the second query will be the yellow ones, the 22, 31 and 74, right? Now there is an intersection here, right? So intersection we have to compute. So what is the intersection going to be? Intersection will be those DIDs which are coming in both of them, right? So which DIDs are coming in both of them? So 22 is there, 22 is there, 31 is there, and 31 is there, right? So this particular query results in two DIDs, which is 22 and 31. Fine. So if we do that, now let's go to the upper query, which is outer query. Select d.dname from diversity where d.did in 22 and 31. So we have to look for those drivers whose DID is in 22 and 31. So what are those DIDs? So we have Karthikeyan, who has a DID 22, and we have to look for 31, right? And we have to print their names, or we have to give out their names. So we select these two. So the answer is Karthikeyan will be printed first because they are sorted in this order, right? So when we do a query, usually the results of the query are printed in the order in which the table is already arranged, and they have already said that this is already sorted by the DID. So 22 will be printed first and 31 will be printed next. So the answer will be Karthikeyan and Boris, right? So let's see which option is this. So if you look at it, A is the first option, which is Karthikeyan and Boris. So this will be printed. Okay. So with this, we complete the PYQs on SQL. Next, we will see ER model or normalization. So I'll see you in the next lecture.